Is this audible now, Priyadarshini?
Yes, ma'am.
Yes, now your voice is clear. Earlier your voice was cracking a lot. So that's why I
Yeah.
wasn't able to hear you.
Okay.
So you're in 12th grade?
Yes, I'm in class 12.
So what's your physics currently your physics lesson going in your school?
Actually, we have vacations going on currently.
Yes, before the vacations.
Uh, we finished current electricity and we were in the first part of magnetism, the fourth
Oh,
chapter.
alright. So that has not been completed. After the vacations, you will complete it in the school.
Yeah, ma'am.
Alright. See, Priya, right now, because it's a short trial class for you, I'll do current electricity. We are doing current electricity right now only in your regular batch, with which you will join. See, we'll do the introductory part of electric current right now, but majorly today will be the last class for electric current. So from the next class means tomorrow we'll be starting with magnetic effects of electric current. That is your chapter number 4, moving charges and magnetism. So even if something has been missed, you will be able to cope up with. Now, what will happen is that current electricity is backup classes we already had. So according with you, whatever classes you want, some of the lessons I'll be teaching you directly, some of the lectures I'll be covering by taking the backup classes or showing you the video recorded lecture that has already been taken in your class. That's how your backup for all the 3 chapters. The first chapter, second chapter, and the third chapter will get over. Right now, today will be the last class for current electricity. So just attend the whole class. How much duration was told you?
I wasn't actually informed about the duration.
Or okay. So see, your main class timings are from 4 o'clock. So 4 to 5:30 is your main timing. So right now, I think your class started at 3:30. No.
I'm currently in India, so it's 6
Okay. All right. You're in India right now. Okay, fine.
Yeah.
Fine. So, Priyadarshini, then your classes are from 6:30 to properly, they're 6:30 to 8 o'clock. Fine. So, for when you will go, so just that's why I thought that you were out of India. So, right now, you had your class today at 6 o'clock. So, 6 to 6:30 will be your try class, and your regular batch will start. So I was saying whatever suits you, then you can do. If you wish, you can continue today only. Otherwise, you can come from the next chapter, that is tomorrow. But let's just have the
Ma'am, actually the tomorrow timing will be 6:30 to 8:30.
not 6:30 to 8:30, 6:30 to 8, 1.5 hours class. Right now, initially we are having 1.5 hours class, then we'll increase the time.
Okay, so I actually have another class during these hours tomorrow.
So which class on this Learnivio only?
No.
Okay, so what are the timings?
Tomorrow Indian time it will be around 6:30 to 8:30.
6:30 to 8:30.
Yeah.
Fine, Priya. See, there are other batches also, so don't worry about the timings and all. That will be discussed by you. Fine, just have the class today. Just see, let's get the introduction. Let's introduce ourselves first. So what will happen? There are other batches also. So if you are not available on weekends every time, is it for tomorrow only or is it for every Saturday or Sunday?
Actually, since we are on vacation, our teachers have been not very constant about the time. So I guess this week every day I have 6:30 to 8:30 tuitions.
All right. So fine. No worries about it because we have so many batches. So whatever timings will suit you, no, there you will pick it. I will tell you all the timings of all the batches and whatever lessons are going. Some of the batches are ahead, they are further ahead, but some of the batches are in their initial state where magnetics is going in all these lessons. So don't worry about the timing. Just have this short class of current electricity at least. I'll just introduce you with electric current. Then afterward, once you get familiar and all, then we can begin with the lesson. Because most probably today your class will end. So let's start. See, electric current is what? Electric current is basically the rate of flow of charges. Now, rate of flow of charges means anything, any quantity that gets divided by time or changes with respect to time. We call it as rate. For example, in class 11th, you must have studied velocity. Velocity was what? Rate of change of displacement. So what did we write? We wrote displacement divided by time. So that became rate of change of displacement, which we called as the velocity. Similarly, electric current is also what? It is the rate of flow of charge. It means charges which are flowing per unit time. And how do we represent electric current? With the symbol I. So I is equal to Q by T, where Q is the amount of charges that flow and T is the time. Now see, electric current SI unit, this is ampere, and it's a scalar quantity. Now just reminding you with what are these quantities. So physical quantities are grouped into two categories. One is the vector quantities, other one is the scalar quantities. So vector quantities are which kind of quantities? These are those quantities that have a magnitude as well as they have a specific direction. Scalar quantities are those type of quantities that have just the magnitude. Now, electric current, we keep it under scalar quantities. Before we move on to the scalar and vector, no, just see one thing. Let's discuss the direction of electric current first. See, if a positively charged is there, a charge is positively charged, the nature of the charge or the polarity of the charge is positive. Don't worry about the writing portion, by the way. I'll give you time to note down all these things. So Q is a positive charge. So what happens? Let's say this is moving in towards the right hand side with V velocity. So what happens to the current? If it's a positive charge, then the direction of current is same as that of motion of the charge. So if charge is moving towards right with V velocity, then current will also move towards the right only. That is known as the direction. So this is for a positive charge. If we have a negative charge, no, let's say negative charge is moving over here. So for a negative charge, the direction of flow of charge becomes opposite to the flow of motion of the charge. So if the negative charge is moving towards the right, the current will flow towards the left. This will be the direction of electric current. So for a positive charge, current's direction is same as that for a charge. And in case of a negative charge, the direction of current is reversed. So for example, you can have proton over here, you can have electrons. So you just have to keep in mind whenever protons or electrons are mentioned, which direction you have to choose for the current. So keep it same for the positive charge, reverse it for a negative charge. Now coming back to the discussion that I was having with you regarding scalar quantities, whether to put electric current under the category of scalar quantity or vector quantity. Because as discussed, vector quantities are those quantities that have a magnitude and direction. Here also, electric current's magnitude is given by this formula. Electric current's direction, this is given by this formula. So magnitude is there, direction is there. So if both of these quantities are there, then electric current should be a vector quantity because direction is also there, magnitude is also there. The reason for keeping electric current under scalar quantities is that this current does not obey the vector laws. Vector laws you might have studied in class 11th, the parallelogram law, triangle law, polygon law, and all these laws. So in case of current, what happens? It's the only quantity that becomes, it's the only scalar quantity that has a direction. But since it does not obey the vector laws, so since it does not obey the vector laws, means your parallelogram law, triangle law, polygon law, any of these laws, we keep electric current under the category of scalar quantities. So it's the only quantity that is scalar but has a direction. Otherwise, simple magnitude can be obtained from here and direction can be obtained from here, but it is a scalar quantity. So these were the introductory portion of it. Now, just one more thing, then you can note down all these points. How to use this formula? I is equal to Q by T. See over here. have two quantities. You have two things with you that you have to keep in mind. One is known as a time duration. So time duration is what? Time duration is when you have a beginning of a time and you have an ending of a time. That means, let's say, for example, if I say t is equal to, let's say today only, let's take the example right now. 6 o'clock, our class has started. So from 6 p.m., the class will be, let's say, it will be till 6:30 p.m. So 6 p.m. to 6:30 p.m. This becomes the time duration. And time duration is what? Half an hour. If I say 6 to 6:30, that becomes what? Then this becomes the time duration. There's a starting, there's an ending. Or I can say 0 to 8 seconds, or I can say 3 to 4 seconds. It has a starting, it has an ending. This is known as a time duration. So if in any case you have a time duration is given by this formula, change in the current divided by the change in the time. This means Q final minus Q initial. This is final time minus initial time. And the type of current that we obtain here, this is known as average current. How did I calculate this? Final time minus initial time means whatever is the change in the whatever is the difference in the charge's value divided by the time duration. And the type of current that we obtain, that is known as an average current. Now, another quantity that is present is known as time instant. So time duration and time instant, both of these are different. Time instant means at a very, very specific time. For example, instead of this, I'll tell you that the time currently, tell me the current for the time that is right now. For example, it's at 6:17. So I'll say, tell me the current at 6:17. Or I'll tell me the current at 3.00004 seconds. Or I'll say, tell me the time for, I'll ask you to tell me the time exactly at t is equal to 8 seconds. T is equal to 2 seconds. T is equal to 0.0000001 second. So at such a time instant, where a very precise time is mentioned, that is known as time instant. So if any of these times values provided, do you know? Then you differentiate charge with respect to time. When you differentiate charge with respect to time, you get a type of current which we call as the instantaneous current. So there are two methods to use this formula, I is equal to Q by T, either by this or by this. First, tell me, is it clear to you?
Yeah, yes, ma'am.
Clear? Any doubts you can ask me? It's just a very introductory portion because you can have an idea of everything. So start noting from here. I'll scroll it slowly, and wherever you are having issues, just ask me.
Scroll down. So, ma'am, when they ask just the current, are we supposed to find instantaneous current or average current?
No, you have to see at what time they're asking. I'll give you an example. Just note it down. I'll show you how to you apply this. Okay, see how the questions will be given. This is an example that I'll show you. It says the charge that is flowing through the cross section of a conductor is given by what? Q is equal to 3t square plus 2t plus 1. Fine. Now the first part is asking you to calculate current in 0 to 2 seconds. So current between 0 to 2 seconds means what? According to you, is it time duration given or time instant?
The duration.
Duration. So what type of current do we calculate? Instantaneous or
Average
average?
current.
Average current. So that's how we decide how to find out it. Now see, what did I tell you? We calculate the final charge minus initial charge. So final charge will be at the final time, that is 2. So just put 2 everywhere instead of t. So that becomes 3 into 2 square plus 2 into 2 plus 1. This gives 17 coulomb. What's the initial charge? At 0. So put 0 everywhere. This becomes 3 into 0 square plus 2 into 0 plus 1. That is 1 coulomb. And the time duration? Yes, Priya, what's the time duration?
2 seconds.
Exactly, 2 seconds. So average current will be final charge, means change in charge by change in time. That will be simply 17 minus 1 divided by 2 minus 0. That becomes 16 by 2, which is 8. So average current comes out to be 8 ampere, which is for the duration between 0 to 2 seconds. Priyadarshini, I want to ask you one thing. Are you clear with differentiation?
Yeah, I'm actually fine with it.
Okay. You are clear, no?
Yeah, I learned
या
it
कहीं पे
through
प्रॉब्लम हो
online.
रही है?
Actually, it gets a bit confused, but yeah, I do know all the basic rules and all.
Basic rules and all. Okay, fine. So
Yeah.
as the questions will come, we'll keep on discussing it. Or if you face more difficulties, no, then you can easily tell me. I'll arrange a class also with you. But I think if the basics are clear, then as soon as the questions will come, no, the rest of the topics will get clear. So see, this is what equation Q is equal to 3t square plus 2t plus 1. What do you have, by the way, in your additional subject, maths or biology, or both?
I'm having computer science. I'm computer science with math student.
Maths, computer science and maths. All right. Then you will not be having so much difficulties. See, current will be differentiation of charge with respect to time. So you only tell me how to differentiate 3t square.
It will be 3 into 2 into t. So it is
Exactly,
60.
60. Perfect. And what about this term?
Just 2
Just 2. And what about
plus
this?
0 plus
0. So your basics are very much clear. It's very good. Otherwise, students are not able even to do this much. It's very good that your basics are clear. Now, as the questions will come, if any difficult question is there or any of the thing that is you required in physics, that we'll discuss. Just your basics are fine. Then at t is equal to 2 seconds, we have to find this is the instantaneous value, instantaneous time. So we'll get the instantaneous current that becomes 6 into 2 plus 2, which is 14. So your instantaneous current comes out to be 14 ampere and average current 8 ampere. Can you see the difference between when the duration was given and when the instant was given? Clear?
Yes, ma'am.
All right. So just note it down. Any queries, any difficulties, just ask me. You're currently at which place, Priya?
I'm in Tamil Nadu.
All right.
Yeah, done.
Both the parts?
Yeah.
Fine, fine, Priya. Then let's stop over here. If you have any queries, you can ask me. Otherwise, if you wish, if you are available, then you can continue today's class also in your regular batch. Students will join after 5 to 10 minutes. Or if you wish, you can.
I'm
That up to you.
free. Uh,
You are available, no?
yeah, I'm free.
All right, all right. So just wait for 5 to 10 minutes. The students will join. The regular batch will start. So you can also have a look at the chapter that we are completing.
So ma'am, so you're taking just for CBSE or
CBSE plus NEET level, CBSE plus NEET and J level. But specifically for the entrance practices, no, we are having other special classes with this, along with this. So are you
yeah, okay.
preparing for any entrance, NEET or JE?
I'll be preparing for J.
For JE, no? So they are also taking certain classes. Means, for example, let's say current electricity has been completed. Let's say it will be completed by today. So in that batch, whatever extra class batch you are having for NEET or JE, you will be having only this chapter class. So there, no theory portion will be discussed because every theory portion and all the basic CBSE plus a little bit of the previous year, a little level of NEET has already been covered. So specifically for your entrances, specialized teachers are there. They are special teachers from IIT and all. They will just focus on numericals. So if you wish, you can also get inquiry about those classes if you're interested in your entrances.
Thank you.
Okay, class. Other students will keep on joining. You people are already waiting. So let's start with it. Other students will join. And Elia has already come. So these will keep on joining. So see, in the extra class that we had on, I think Monday we had it. On 15th, we had this extra class. So we had completed the portion of resistance and resistivity. Some students were to be added on the WhatsApp group. So that's why I didn't send the other videos. If time is permitted today, after the completion of the last topic that is left, then I'll be discussing those topics which are left after the resistance. Resistance and Ohm's law, I think we had the first portion we had covered, resistance and Ohm's law. This part was left. Regarding Ohm's law, I think we have covered till Ohm's law. Right, class? Yes, drift velocity and all these topics we had already covered. So fine. So if today time permits us, then we'll discuss these. Otherwise, I'll definitely send you the videos as well. Now, Kirchhoff's law has already been discussed. Remember, we derived the Wheat-Stonebridge expression as well using Kirchhoff's law. Balancing condition of Wheat-Stonebridge. So that becomes very important from Kirchhoff's law. Normal circuits like these will be given to you in exam. This is a question from your NCERT only. So circuits like these will be provided to you. And out of all these circuits, any of the circuits can be used. So simple law that we have studied that you can apply. Then this balancing of Wheat-Stonebridge. This is important. Balancing of Wheat-Stonebridge is important from your theoretical point of view. 5 markers question come to prove the balancing condition of Wheat-Stonebridge. That we had covered it on last Sunday, I think. Yes. The last topic that is left is the combination of identical cells. So again, repeating all those small topics, no, internal resistance, EMF, terminal potential difference, those just require 2 classes. So either I'll take the extra class or it's better I'll send you the video lecture because some more students are there. So they'll have an overview of it. Let some students join, then we'll start. All right, class. Now, combination of identical cells. What is meant by combination of identical cells? See, when there are different cells connected, so we'll have internal resistance of the cell. I'll just brief you with what is meant by internal resistance of a cell. So the cells now that you see in your regular circuits, they are actually composed of electrodes, and these electrodes, no, these are dipped in the electrolytic solution. This is actually the internal structure of a cell battery that you see. So what happens? This electrolytic solution as well as these electrolytes, both these provide a resistance to the cell. And since it's the resistance within the cell, so we call it as the internal resistance of the cell. To write it, to represent it, we write it along with the cell in this manner. So this becomes your cell with certain EMF, and this small r represents the internal resistance of the cell. So it's not like a resistor has been connected in the circuit. This resistance is within the cell only. And this is the external resistor connected. So now what we'll see, if the cells are unidentical, we had already seen this. So for students who were not there, I'll just brief you with it. Most of the students have had this series and parallel combination did together. See, in case of series combination of cells, when you have the series combination of cells, E1, E2, E3, these were the different EMFs that were there of the cell. And R1, R2, R3, these are the different internal resistance of the cell. This is the main formula. Ohm's law, at least all of you should know Ohm's law is what? V is directly proportional to I, so V is equal to IR. Potential is the product of the current and the resistance. At least this much you should know. Based on this, we have written the formula of current. Potential, that is the EMF divided by the total resistance. This is from Ohm's law. So this is important for you. At least this you should know. When the cells were different, we had to add all the EMFs together, and then we have to add all the internal resistance together. Now what is happening? In combination of identical cells, no, all these EMFs become the same because cells are identical. If the value of EMF for the first cell is 5 volt, then for the second cell also it will be 5 volt. For the third cell also it will be 5 volt. Means all the cells are exactly replica of each other. So in this case only, see class, if I tell you to add the equivalent EMF, so if I ask you to calculate the EMF, what will it be? Let's say n number of cells are there. N is the number of cells there. So it will be E plus E plus E. Up till how many E's will be added? Till the number of cells which are present. So this will be what? This will be simply N multiplied by E. Let's say 3 cells are there. Let's say N has the value 3. So E plus E plus E will be what? 3E. So isn't it N times E? The result is actually N times E. That's what I have written. E plus E up till whatever is the number of EMFs present. That will be NE. So in series combination, what will happen? All the EMFs will get added, and or the next way method to write it as to multiplied by the number of cells. So number of cells multiplied by EMF for a single cell, that gives you equivalent EMF. Any doubts, any confusion, ask me. If you people are not able to relate with the past topics, then also ask me. I'll repeat the topic also. If you're hesitant to ask, you can even type in the chat box. Regarding the internal resistance, see internal resistance, what will happen to the equivalent internal resistance? See equivalent internal resistance, all the internal resistance will also get added. This will be what? R plus R plus R up till what value? The number of R that is present, number of resistor. Let's say n number of cells were present. So this time also the resistance will become n into small r. So equivalent internal resistance is this, equivalent EMF is this. What's the external resistance of the circuit? External resistance. This is capital R. This much information has been given to us in series combination. All these were identical cells which were connected in series and they were connected to external resistors. Now, value of current. See, right now only I have told you on application of Ohm's law. See, when we'll apply Ohm's law, what will be the current? Current will be total voltage, that is the EMF of the cell, total EMF of the cell, E equivalent, divided by the total external resistance of the cell plus total internal resistance of the cell. So I is equal to E equivalent divided by R plus R equivalent. How am I writing this? This is the total resistance and this is the total voltage. And current using Ohm's law is what? V divided by R. Do not forget Ohm's law. Questions from Ohm's law directly are not asked. The statements are just asked in your exam for Ohm's law, but you have to specify if the questions are asked. Ohm's law applications are wide. Now see, I will be equal to E equivalent divided by R plus more R equivalent. So what is actually E equivalent? All the E equivalent means if you say the equivalent EMF will be N times E divided by what's the total resistance? Capital R plus small r. But right now we do not have small r. We have N times R for the N number of cells. So that becomes N into small r. So this is your formula of current for what? For the series combination of what type of cells? Identical cells. Because if the cells were not identical, then it would have been E1 plus E2 plus E3 and we would have not received N times E. If the cells are identical, then only we write Ne divided by capital R plus small nr. Here, N is what? N is the number of cells that are present. E is the EMF of a single cell. Small r is what? Small r is the internal resistance of the cell. N is the number of cells only. Capital R is the external resistance of the cell. and I is the current. So I is equal to NE divided by capital R plus small n into R. This is the formula that we use. Now there will be certain modifications in this formula for certain cases that we'll discuss later on. First, just note down these 2 to 3 points first. Then we'll discuss certain cases. There are 2 cases in each, series combination as well as parallel combination. And both the cases are important from your examination point of view. Especially this series, this identical cells, no, these are important not only from your 12th board's perspective. For your entrances like NEET, J and all these, this topic becomes important. Combination of identical cells. Because calculations, all these steps are reduced. So that becomes easier to solve. Series combination, you have certain points, and then you have certain points for parallel combination. So quickly note it down, then we'll see these 2 cases. Ashwarya, you wanted a class on electric potential, no? Just tell me the precise topic which you were having difficulties.
No, ma'am, it was for the exam. The exam's over now, so it's fine.
Okay, all right. For the exam, you wanted a class.
Yeah, it's fine. It's over.
So how was it? Was it fine?
It was okay.
Your school is not having the summer vacation right now.
No, I'm in India right now. I'm in Kerala.
All right.
I'm
Okay.
studying.
Whenever any one of you is having exam, no, and the studying of the topic is urgent, like Ashwarya's topic was urgent, she wanted a class for her exam, but the message couldn't be conveyed that it's for the exam. I thought she was having difficulties in the topic. That was what I was told. So if any one of you is having any of the UT or any topic has not been discussed or covered, or you want another class or your exam is approaching, so you can directly write it on the WhatsApp group, or you can text me personally also on WhatsApp. Just text your name, tell me who is the person, and you can let me know. I think all of you are added on the group, no, except for Priya. Other students are added?
Yes, ma'am, I'm added to the.
All right. And I think your new numbers, Astha and all, have they been added?
No, ma'am.
Yes, ma'am.
Astha's is not. Okay, Astha. I'll remind them once again to add yours. So if anyone is having any issue, no, regarding it, so you can take, even if you people are having doubts from your assignments or normal, whatever books you're solving. So that also you can send the pic to me. I usually do this thing for the doubt solving. No, whenever the student sends the picture, then I also write it in the register and send the solution. Even if it does not clear, then we can have a class. So just text me on WhatsApp anyone is having exams or something. Because now after your schools will be reopened for the other students whose schools are closed right now. When your schools will get reopened, you people will be having, I think, your tests and all for at least the 4 or 5 chapters. So just let me know whenever you people are having exam. I think one of the students from this batch only mentioned magnetic field or EMI or something was coming in the exam. Yes, written class.
Yes, ma'am.
All right, if anyone is writing, just stop me, otherwise I'm moving forward. Now see the cases that we have. Cases are basically when the external resistor is greater than internal resistance. See, once again, let me tell you the difference between internal resistance and external resistance, just the physical meaning different. See, when we connect the wires, whenever we connect all the wires, what happens? When we connect the wires through the circuit to the resistor, we form the full circuit. So all these EMFs, all these batteries have a certain EMF, and the resistance that is present within this cell, that we call as the internal resistance. So internal resistance will be present in any way. You have a battery, you have seen a cell, a normal cell you have seen. Inside it, there will be a mechanism where electrodes will be present, electrolytic solution will be present. That you study in your electrochemistry and all these lessons. Right now, what you have to understand is that in the cell, this resistance will be present. This external resistance, no, this is what? This is the resistor that has been connected externally. All the circuits, no, we had seen when we were solving the series and parallel combination. There were so many circuits that we have seen. All these circuits. So regarding these circuits, what happened? All these circuits. What happens when you have all these circuits? These are the external resistors which are connected. Separately, you connect all these resistors. You take with the help of wire, you fix these resistors in your circuit. In case of internal resistance is situated within the battery itself. So external resistance, you people know how to find out the R equivalent of external resistance using series and parallel combination. Most of you know. For students who were not present, I'll send you the video lecture and we'll discuss the backup for it. So first case is when your external resistor is greater than your internal resistance, and second case is when your internal resistance is greater than external resistance. Fine, so two cases are present. So firstly, understanding of this, whether your internal resistor is what or external resistor is what, that is crucial. Because once you are aware of this, external resistor is a resistor that you have been studying and solving. Internal resistor is this resistor that is new right now. External resistor, you know how to solve. Internal resistor is that resistor which is present in the cell, within the cell. You need not connect it to anywhere, that is already present or located within the cell. So one thing is clear in your mind, that external resistor, these resistors are already present within the cell and these are present at the time of manufacturing of the cell. Fine, class. Now, external resistance equivalent circuit, once it will come, then you will be using your normal series parallel combination. You will be using your Kirchhoff's law. Kirchhoff's law also we have covered. So all these resistors will be then get utilized. But whenever internal resistance are there, for internal resistance you can directly add it. Just directly add it, you will get the values of internal resistance for the cell. Now, when your external resistor is greater, external resistor is not just greater by a smaller amount. External resistor of the cell is greater by a huge amount. This arrow, this symbol is showing that your external resistor is very much greater than your internal resistance. So here in this case, what is happening? Your external resistor is having such a value which is so much greater than the internal resistance. So something that is very huge. This is very huge as compared to your internal resistance. So when this is very huge as compared to your internal resistance, will there be any effect on the internal resistance that you have? See, what was the equation in the denominator that we had? This was capital R plus NR. Fine, this was our equation, capital R plus NR. This was the main equation. Now we'll be using this equation and seeing the modification. This equation, when do we have to use this equation? We have to use this equation when it's a normal case. R and small r, both are comparable. But if they are not comparable somehow, means one of the quantities is greater than the other quantities, then what do we use? For that case, we use the modification of it. Modification as in, see, external resistor is greater. External resistor is greater, it means this is something very huge as in comparison to what you have been studying about the internal resistance. So in this case, what happens, class? External resistance is this much huge external resistor is present. So when you will add internal resistance will be a very smaller number as compared. So it's like if you have 1000 with you, in 1000 you're adding 1. So what will be the answer? 1001. So you will say what? What's your answer? You will say it's 1000 only. Or will you tell that it is 1001 precisely? Approximately what will be your answer whenever you are asked to add 1000 plus 1, or even leave 1000? The way we did infinity case. What did we do when we had infinite resistors in series? We had infinity plus a very small circuit. So what did we do? We wrote it as the equivalent resistance. Here also, this R is greater. So this R, let's take this is 1000. And small r is very small. So NR is very small. NR is 1. Answer will be 1001, which we'll write approximately as 1000 only. So can any one of you tell me if capital R plus NR is written, what can we approximate it to? If capital R plus NR is written, what can we approximate it to? Anyone? Like here, 1001 could be written as 1000. So R plus NR could be written as? Yes, someone is answering. Capital R, right. It will be written as capital R. See, if you have capital R with you, which is a very huge number, and you're adding NR, which is a very small number, so there won't be any effect on the value. The dominant factor is what? Capital R. So you can approximate it to capital R. See, understand this first part clearly because rest of the parts will be similar to it. So I'll not be taking so much of time to discuss this. It's like 1000 plus 1 will give you 1001 only. So 1001 will be what? Will it be approximately equal to 1 or 1000? Obviously, you will say 1000 because the greater one. Or you can say in the huge ocean, if you add a drop of water, there won't be any effect. You will say you will not consider the drop of water that you have added because it will get mixed up with the whole ocean. So similar here also, you have capital R plus NR, which is equal to R. If anyone disagrees with this fact, let me know. I'll clear your fact if anybody is having doubt in this, because this part is important. Rest of the parts are replica of this. Now formula was what? Formula was NE divided by R plus NR. Now R plus NR is what? R plus NR is capital R only. So if you have the value of external resistance very much greater than internal resistance, then just simply use this formula NE divided by R. And when to use this formula? You have to use this formula when the maximum current is asked. If maximum current is not asked, then just compare these two, see which series or parallel combination will be preferred. That we'll see. We'll see a question that we'll discuss. Now, contrary to it, small r is greater than capital R. If small r is greater than capital R, then what can we write? And this R plus NR. Can anyone answer? R plus NR. If now this time small r is greater. Yes, Anushka.
Ma'am, it will be smaller.
It will be small r. So it will be not this time, it won't be this term. This time it will be small nr only. Now see what is the formula of current. Ne was already there. Now we have what? Instead of r plus nr, we have written it as n into small r. If we have written it as n into small r, n gets cancelled. Current is written as E divided by R. Both, all of you tell me, see both of these formulas. Which one is greater? N getting multiplied by this term or just this term? The first one or the second one, according to you? Which term is greater? Which current is greater? I in see this term is greater. Reason is that here you just have E divided by capital R. Here you have E divided by small r, but this is N times E divided by R. So the current is greater over here. This is the maximum current that is possible. So out of both these, no, when you have series combination, when to use series combination better so that we can have a greater amount of current. So that you will be understand with the help of question only, but still just for your knowledge, keep in the back of your mind that series combination will be preferred if you have external resistors value greater than the internal resistor. Whenever external resistor is greater than internal resistor, you will prefer series combination. Why? Because when external resistor is greater than internal resistance, then you have the maximum value of current and you get a huge amount of current. When we talk about parallel combination, see parallel combination, what happens? E is the EMF of the cell, R is the internal resistance. Let's say M identical cells are connected in parallel. Can anyone answer this correctly? Or at least all of you should try. All of you write me in the chat box. Whatever be your answer, it's okay if it's correct or incorrect, I'll let you know. But I just want to know from all of you. What will be the equivalent EMF of this? M is the number of cells that are present. E are the amount of cells that are present. Can anyone answer what is the equivalent EMF in this case? Or at least write in the chat box, write down to me, what's the equivalent EMF? Like it was N into E in case of the previous one, series one. So what should be the value over here? Asta, N is not there. Priya, I've got your answer. Asta, N is not here right now. You have M number of cells. M I have taken just to differentiate it with N so that you do not get confused that N it will be for series and M will be for parallel. Okay, Asta. Asta and Priyadarshini have answered. Others class? Respond, students. I'll tell you the correct answer. Anushka, Ashwarya, Razan. Right, Razan. Correct. C. Correct answer has been given by Razan. What did we study in case of parallel combination? Which quantity remained the same? Anushka, do you remember which quantity remained the same in case of parallel? Current or voltage?
Ma'am, voltage.
Voltage. So this is what? This is your parallel combination. Here what will happen? All the cells will be having the same EMF, whichever is the EMF of the whole circuit. So in this case, voltage will be the same. How will you calculate the equivalent EMF? So rightly answered by Razan, equivalent EMF in this case will be E only because this is parallel combination. For you, Priya, because you were not present in the earlier classes, whenever series combination is there, in case of series combination, you have current as the same in the entire circuit and voltage gets divided. Whenever there is a parallel combination of circuits or cells are present or resistors are present, what happens is that voltage remains the same and currents gets divided. Means every branch will have different value of current, but the value of voltage remains the same. So here also equivalent EMF will still be E. In the last case, it was EE, means E got added, E plus E plus E. So it became N times E. Right now, what has happened? Right now, EMFs are same for the entire circuit. So equivalent EMF will be E only, which is EMF for the entire circuit. Fine. Now see, if equivalent E is this, equivalent EMF is E, let's talk about internal resistance. So these resistors are connected in parallel. And you people have studied how to find out resistors which are connected in parallel. What's the equivalent resistance of resistors which are connected in parallel? So can anyone tell me what should be the value of equivalent internal resistance? Just take it normal case of parallel combination, parallel addition of resistors. M cells are there, what should be equivalent resistance? This I have told you also. If identical cells are there, how to find out the equivalent resistance for parallel case. Nobody? I have not received any answer. See, how do we calculate the resistance, equivalent resistance for parallel combination? By reciprocally adding all those quantities, means reciprocally adding the individual resistance. So R 1 by R equivalent will be what? 1 by R plus 1 by R plus up till how many times? M times 1 by R. So this is M by R is what? The equivalent resistance will be what? Equivalent resistance will simply be M by R. This is what? This is 1 by equivalent resistance. So what should be the equivalent resistance? Equivalent resistance will be R divided by M. So this time, E equivalent is E in case of parallel combination and R equivalent is R by M. Whereas in case of series combination, you had E equivalent as NE and R equivalent was NR. Now putting in the main formula of current that you have. Main formula of current, this will be C what? I will be equal to value of EMF divided by the total resistance. EMF is what? This time EMF is E only. Last time it was NE. This time it will be E only simply. Divided by external resistance plus R by M. So if you take out the LCM, you get the value as ME divided by MR plus small r. This is the value. What was it in case of series combination? It was I is equal to NE divided by capital R plus N into small r. This time in case of parallel combination, it is I is equal to ME divided by M capital R plus small r. Fine, by using normal LCM rules, where M and N both are the number of cells that are present. M is actually the number of rows because in parallel combination, rows are formed. In case of series, that was the number of cells that were connected. Fine class. Now see, we'll have the same modification here also. Before moving on to the numericals, now just have an idea of this. Here also we'll be having the same modifications. See, now the denominator is what? Denominator is MR plus small r. So if this is the case, Astha, can you tell me how will we approximate it to? M capital R or small r? Astha.
Capital R.
Capital R. M times the capital R. Perfect. Because this quantity is huge. Even if you add small amount of internal resistance, that won't affect it. So if this quantity is huge, this will dominate. Now, what was the formula of current? ME divided by just it will be MR because this pole has been written as M into capital R. M gets cancelled, I is equal to E divided by capital R. If we have this small r, so M capital R plus small r, this should be equal to what? Laya, can you answer? What should I approximate and write it to?
M and small r.
Just small r. Just small r. This time. Because this is a bigger number. M is associated with capital R only. So whenever capital R will dominate, MR will come. But small r is having no coefficient with itself attached to itself. So it will be just small r. So yes, right, Laya. It will be small r. So what will we write? We'll write M into capital E, and instead of this whole denominator, we'll be writing just this value of small r. Now see class, this is greater or this is greater? First case is greater or second case is greater?
Ma'am, second.
Yes, Anushka, second case is greater because here you are having M times something. So in parallel combination, what we'll prefer? Whenever your internal resistance is very, very much greater than your external resistance, then you take the parallel combination of resistors. Parallel combination of resistors is preferred. And in case of series, we had the opposite thing. External resistor had to be greater than internal resistance. So these are the cases, parallel and series combination of identical cells, and you have to remember the values and the formula. So till here you people have written, start noting from here. Any queries in between, any doubts in between, ask.
Ma'am, could you scroll up a bit? Yes, ma'am, done.
So all those who have written, just try this question. We'll discuss this. First note it down, try it yourself, then we'll discuss it after 5 minutes. 8 identical cells of EMF 2 volt, these are connected. Internal resistance of each is 1 ohm. See, in this case, no, external resistors are mentioned. So how to solve it? You will solve this by first identifying, compare external resistor with internal resistor. See which combination you have to prefer. Once you know which combination you have to prefer, then you can easily solve it. Let's discuss it then. So did anyone try any answers for the first part, second part? Okay. Yes, Razan. A is parallel, B is series. But did you find the current? You have to find actually the current. See, good. Razan, you have actually completed the major portion of this. Now just identification is left. Mariam, have you joined just now? All right, Mariam. C class. External resistor in the first part. External resistor is what? 0.05 ohms. Your internal resistance is what? 1 ohm. Capital R is greater or small r is greater right now? If you see over here, your external resistor, this is very much small as compared to your internal resistor. So this will be what? Internal resistor is very much greater than external resistor. Just now you people have written it in your notes that whenever your internal resistor is greater than your external resistor, the type of preference you will choose is the parallel combination. So you know why this data is given. This data is just given to let us select whether parallel combination is there or series combination is there. So this shows that parallel combination is there. Now, if the question had asked us the maximum value of current, then we would have used the reduced formula. This formula, this is the formula for what? This is the formula for maximum current. But right now, no information regarding the maximum current is used. So we'll prefer the formula of parallel combination for current, this formula. Fine class. That selection, whether it's a parallel combination or that decision, whether it's a parallel combination or series combination, that is chosen by that. But now further, which value we should put in the formula, whether we should use this current formula or the reduced formula, is by the value of maximum current. Right now, maximum current is not asked to you, so we'll use the general formula for the parallel resistors. So what this will be? See, current is written as M into E divided by M into capital R plus small r. Now, number of cells is given as what? Number of cells are given as 8 cells. So this becomes 8 into, what's the EMF given? 2 volts. No, I think, let me just check. So this is given as 2 volts. So 8 into 2 divided by 8 into external resistor is 0.05 plus internal resistance is 1. Once you solve this, you will get the answer as 11.42 ampere. Just check it once after the class. That becomes your current for the first part. Let me know, is this part clear to all of you or any doubts and difficulty in this part? Because the second part is very easy once you've understood the first part. Anyone wants me to repeat any of this? Just let me know. So I'm assuming you people have understood. Now second part says what? Second part says what's the value of external resistor? It's 100 ohm. So external resistor is 100 ohm. Internal resistor is 1 ohm. 100 plus 1. 101, that is almost 100. So external resistor is greater or internal resistor? Which one? Just compare, 100 is greater or 1 is greater?
External resistor is greater.
External resistor is greater. So whenever external resistor is greater than internal resistor, we prefer series combination. And for the series combination, we had the formula. Remember, N into E divided by R plus NR. Because maximum current is not asked, so we'll use the normal formula for series. Number of cells will still be 8. I will be equal to N into E is 2, capital R is 100, plus N is 8 into 1. this will be around 0.148 amperes. Fine. Just check the calculations after the class, match it with it. So this way you have to use it. One last case is left, mixed grouping. But before we start with mixed grouping, no, just note down these part, the solutions. Wherever you are having issues, difficulties, ask me, because this portion is included in your syllabus and questions do come from this part. Done, class?
Yes, ma'am.
All of you have written? If anyone is writing, then let me know. I'll stop you. Mariam, do take this class recording, today's class recording, the initial portion that have been missed by you, because the major part have been covered before you joined. So just take the recording. So tomorrow we'll be starting with chapter number 4. Biot-Savart's law will be the first topic. Then you will be having your tests also. Right now, I didn't take any of the tests from this lesson because many students came in between. But then we'll be having tests as well. Now class, let's move on to mixed grouping. Mixed grouping, questions rarely come from mixed grouping. Okay, Mariam, no issues, fine. See, maximum questions come from your series combination and parallel combination. Series and parallel combinations are very, very important. Mixed grouping questions also come, especially in your entrances, these questions come. For your CBSE level, for your class board examination, most importantly is your series combination and parallel combination, then revise mixed combination. Now mixed grouping is easy. You have understood parallel combination separately, you have understood series combination separately. Now if I combine series and parallel combination together, the type of grouping that I'll obtain will be known as mixed grouping. See, what is meant by mixed grouping? Here I have connected all the cells. Just look at the first row first. Just look at the first row. Isn't it similar to what we have studied for series combination? This is only what we had studied for series combination. All the cells were added together and they were having their internal resistance value, which were getting multiplied by n, because n was the number of cells that were present. So the first row, if you look at it carefully, if you look at this row, just this row, this is basically what? Equivalent EMF was what? N times E. Remember, for series combination, we have done it in the beginning of today's class. And small internal resistance was what? Small internal resistance was equal to N into R. So let's say, let me reduce the circuit. Let me just reduce the circuit. So this was the whole circuit that I had. Now I have reduced the circuit. Means for the entire row, no, instead of writing this entire row, I'll write it as a single cell which has the equivalent EMF. So I'll write this as this single cell which is having the equivalent EMF as NE and internal resistance as NR. I have just reduced the circuit. Remember when we did series and parallel combination of circuits, how did we write it? We wrote it in this manner only. We kept on removing the circuits, we kept on removing the resistors as our circuits got solved. So similarly, the entire row I have replaced it by NE into NR. Now the part does not end over here. Here we have not a single row is present. There are m number of rows that are present. So it means NE, this term, then over here we'll be having this term. So all these terms are connected together. So now you will I have reduced the circuit NE, NR, NE, NR. Like this, I have reduced the circuit. So how many rows will be here? M times the rows are present, and that is connected to the external resistor. Understood what is meant by mixed grouping? The formula and everything is now easier because you just have to relate it. But first understand what is meant by mixed grouping. In mixed grouping, what do? We have all the cells together connected in series first. When the cells are connected in series, you reduce it and then all the cells are connected in parallel also. What happened when we discussed parallel combination? Only this row was there. Only this row was present when we did parallel combination, right? Only this row. And in series combination, only this row was present. Now we have all these entire rows together. That is known as mixed grouping. Now I have reduced the circuit, all the series circuit into parallel. Now we just have to solve this parallel circuit. Series circuit have been reduced, NE, NR. Parallel circuits we have to solve. Now can anyone tell what will be the equivalent EMF of this circuit? Equivalent EMF of this circuit. Is Razan here? Razan got the right answer last time. Razan, can you try? It will be? See, this time it will be NE. See the difference. Here, each cell is having EMF NE. So NE becomes now your equivalent EMF. In the parallel combination, we had E everywhere. So equivalent EMF came out to be E only. This time, equivalent EMF is NE for each cell. So NE. So total voltage will remain NE only this time. Is this point clear to all of you? This mixed grouping is a little bit just more elaborate version of the series and parallel combination. So equivalent EMF becomes NE. It's just that instead of E, which we had everywhere, we have replaced it with NE. All the E's that were present. Okay? Now here, internal resistance that are present. Internal resistance will be what? Internal resistance, C. M number of rows are there. R is already present. So it's like R equivalent will be what? 1 by NR plus 1 by NR plus up till M times the value of NR. That becomes M divided by NR. In previous parallel case, what did we have? We just had M divided by R. Because resistance of a single cell was R only. This time resistance of a single cell in a single row, it became N times R. So we have written it as M divided by NR. So this is 1 by R equivalent. So R equivalent will be what? R equivalent will be NR divided by M. So E equivalent is this, R equivalent is this. Now we just have to write the formula for current. So current will be what? Current will be E equivalent is NE, R is R, and this is NR divided by M. So when you take the LCM of this becomes M, so M will go up, that becomes NM into E, M gets multiplied here, that becomes MR plus N into R. This is the formula of current, where each term is what? N is the number of, M is the number of rows, N is the number of cells in a row. And current, just remember this one condition. If when the current is maximum, no, then MR is almost equal to NR. Then you say current is maximum. First, tell me, any doubts in this formula up till here? Yes, class. Clear to all of you? Is it getting clear to you, Priya Darshini?
Yes.
All right. Laya, Abdullah, is it clear to you? Abdullah Ali? What about you, Laya, Astha?
Yes, ma'am, clear.
All right. So noted till here also, mixed grouping can also be asked. A derivation of this part is usually not asked in your board exams. Just these formula portions are asked. The way we did that question. It's from your previous CBSE question. So note down this part as well. Priya, I want to ask you one thing. This timing, no, that you've been telling me about your extra classes that you'll be having, all those extra classes on your extra classes. So is it till your summer vacation only?
Yes, ma'am. Till September. Yeah, till August 31. I guess. Yeah.
August 21.
No,
That
August 30th.
August 30th.
Yeah.
Then after that, when your school will get reopened, then your schedule will be back to normal, means you will be available in the evening.
Yeah, I'll be free weekly twice.
Okay, okay. C class, one little topic that is left now in this lesson is this heating effect of current. So heating effect of current, mostly you just have to remember that the definition of power. Power is what? Power is basically the rate of doing work. Work done divided by time, the rate of doing. So heat divided by time, which is known as power. So there are three formula for power in terms of current and resistance, you can write it as I square R. In terms of potential, you can write it as V square by R. In terms of voltage and current, you can write it as VI. So if any question comes, if anywhere it is utilized, just directly this formula gets used. Only simple questions are asked. Now, major portion of this is covered in AC, where you have a proper section for power. And after this, then you have one, like similarly this also, you will be having one question in case of one definition of power in EMI. Maximum portion is there in AC. So from here, you can say heat is what? Heat is basically power getting multiplied by time. So that becomes I square RT. This is power getting multiplied, and this is your time. So power by time multiplied by time, this is heat. And SI unit of power is watt. So these points you have to remember, certain points. Maximum portions of this, especially this part, this is used a lot in alternating current. So when we'll reach alternating current, that time we'll discuss it. But at least you should have a brief idea if any of this formula is utilized in your current electricity. So note it down. When you'll complete writing down, text me done in the chat box. So I'll get to know that who has written it or who has not written.
Ma'am,
Yes, someone was asking. Yes, Anushka.
yes, ma'am. Ma'am, I just wanted to know that probably in our school by mid-September we'll have our half-yearly exams. So by that time, how many chapters will be done?
Mid-September, see, we'll start with magnetics. Major portion of your first book that is left is magnetics only. Means your moving charges and magnetism. Because that is a lengthy lesson. Biot-Savart's law, its application, then Ampere's circuital law is also huge. Then comes those little topics like force between two conductors and all these topics. So once that gets over, because that will take time and we will consume time. We will get slow in that lesson because that is the basic for your magnetics. Once that is over, your chapter 5, your chapter 6, your chapter 7, chapter 8 are just 2 to 3 classes lesson. EMI is such a short chapter that in 3 classes it will get ended. Magnetism and matter, that is your chapter 5. That's also a very short chapter lesson. In 1 classes or 1.5 classes that will get over. Alternating current is a little tough. It's tougher than your EMI, but it is also short. And EM waves is definitely very short. So major portion that is left from your first book to complete, apart from these lessons, electrostatics is your magnetostatics, which includes your magnetic fields of electric current, magnetic effects of electric current. And class, for others also I'm telling, it's good that Anushka has asked this. See, your chapter 1, chapter 2, chapter 3, chapter 4. Chapter 3 is this current electricity till your chapter number 4. These are your core chapters for electromagnetism. If you are well with these chapters, you will be able to manage rest of the chapters. Fine. Rest of the chapters means the whole book. In your second book, the only optics is tough. Other portions are very easy. Now your last chapter also does not come those communicating systems, all these lessons. So Anushka, regarding your query that you had, magnetic effects of electric current, that is moving charges and magnetism, that will consume a bit of time. Or even if most of the students are going to have their half yearly, I'll take the extra classes if possible to complete it before. But I think till mid-September, your 5th chapter, it should be over. Till 5th chapter, we'll try to complete it. So if you people have your syllabus with you, you can send me it on WhatsApp. So I'll have an idea, all those who are going to have their tests and all. Or what we can do, because C class, that chapter 4 is very important. Fine. So when chapter 4 is very important, so we have to go slow in that lesson. Then we'll cover it. See, in some of the batches, we are doing alternating current right now. So it's not like that we had started magnetics such a long time back. It's just that once magnetics is over, that's the base, and if that is done well, then rest of the chapters become easier. So what we can do, we can go normally at the normal speed and that, and whenever your test or classes come, you can inform me prior. Like Ashwarya tried, but that couldn't happen because of the communication gap. But that's what I was saying to all of you. Whenever you're having your exam, not just a day before, at least a week before, you all are aware of their syllabus, you all are aware of the condition that you are having, you are aware of the syllabus that you people have completed. So you guys should just text me on WhatsApp or just write it in the group. Then accordingly, I'll arrange your extra class. So at least we can have 1.5 hour class so that you are able to at least score in your exam. Then rest of the concept and the basics you can improve later. Fine?
Yes, ma'am.
All right. So I think most of you have done the